So start by drawing this up, okay? So draw this curve. And put in the explanations of everything for me, okay? Any suggestions for today's... Oh, here we go. Oh, I got it. Can you tell me in chat when you're done writing this down for me? Okay. I'm going to move it down in about 27 seconds. Alright. I know you took a picture, Alicia. This is... I'm not going to tell you where it is first. Okay. I'm going to scroll down. And you can write these ones down here. Okay, one more minute. Work for you guys for this? You can write when you're done writing everything down. Is anyone still needed up? Press yes in the chat there. And we'll get started. Okay, so just in case you lose this page, it's also in your week 4 notes right now. Probably included in your, if you go into your week 4, it should be right there. Oh, also, some of you may have seen my answer sheet. I must have copied over the wrong answer sheet for today's work, this morning's work, into the folder. So I put it, I put the answer sheet for this morning's work in the very bottom of week 4. Then your reassign function note. Okay? So where's my lesson? Okay. So what we're working on right now is an introduction to the next unit. And the next unit is looking at sine functions. Okay? They're periodic functions. Okay? Periodic functions are any, oh boy, what just happened? Alright. Periodic functions are any pattern that is repeatable, is repeated. Okay? So I'll take this one out here right now. Let's not look at that one. Let's look at these guys. Okay? So if you look at this here, all of these repeat in a pattern. Okay? They repeat in a pattern. This is straight down and so on and so forth. Up, down, up, down. This here is actually a sine curve, which we'll start learning about. But everything, repeatable pattern. So if we kept going on this, right, even this one here, it's kind of ugly, but it looks the same thing over and over again. Okay? So I want you to tell me, I'm going to pull these 3 in. Hopefully they show up. Where'd they go? Okay, disappeared on me. Let's try this again. Copy. Paste. Of course, that doesn't want to show up. Save the image. Right. So I'm going to pull over a pattern for a periodic. I'm going to bring over a graph, and you're going to tell me if it's periodic or not. And periodic just means, does the pattern, oh my gosh, every graph I want to pull over right now is refusing to come over. All right. Yes or no, is this periodic? As in, does it repeat itself over and over again? Can I get a yes or a no on that in chat? Yes. Good. Alright, so yes it does. How about this one? Is this periodic? Ben says no. No, no, no. Okay. Why is it no? Can someone tell me that? Someone tell me why you say no to that. One second. They're all the same. Good. So it changes size. The pattern may be the same, of which it is going up and down, but the size is not the same. Good. I'm going to show you I'll show you the most famous pattern in the world. Let me see. You can tell me if this is a periodic. And then who can tell me what this actually is? Is that periodic? Yes or no? Oh, McCann, I missed your comment there. That's an outstanding comment. So Tanner was right. This is a heartbeat. And it is periodic. Okay? It should be periodic. Right? So it has the same pattern over and over again. Right? It's called the PQRST pattern. Because those are like little nodes that you look at. Like if you went to the doctor and you're having heart issues, and they look at those, like if there's something off there. So no matter how hard your heart beats, the same beat takes place in the same section each time, right? And those are actually different pulses in different places in your heart. Try to figure out if I find a heart that's not working properly. All right. So let me see if I can grab this picture I had earlier. Just trying to get a picture to put up here. Where did it save to now? Save image as, where did it go? Pictures. I know this is very exciting for you. Put it on my desktop. Find it there for sure. Okay. Let me get to my desktop over here. I'll show you this then. Okay. So, are all three of these... Where did it go? It was just there. Don't ask me this again. Okay, there we go. Gosh. Microsoft Edge, you cannot be my default Internet Explorer if you crash my computer. Okay? So looking at these three here, as my computer continues on. A, B, C. Which are periodic and which is not periodic? Can you tell me that? Are they all periodic? Are some of them periodic? A and B are periodic. Do we have agreement in that? In chat? A and C are periodic, but C is not. Good. Excellent. So the first thing we have to know is just identifying periodic functions. Okay? Then, let's go back to, I'll blow this one up. Work with a couple of these. So we understand what periodic functions are. Now, let's work with some definitions and some meanings of periodic functions. Okay? So when we use terminology, we'll be able to talk in the same language. Okay? So looking at your note here, we're going to take a look here. Okay? And we're going to start with the We're not going to start at the very top here. So looking here at this one, if we look at max and min, okay, max and min. Max is the highest point, min is the lowest point. What is our max for this periodic function? Someone tell me? 1, good. And what's our minimum for this periodic function? -1. Good. So that's max and min. So we can take a look here. These all look, let's say one that's different. These are all max and mins of 1. That's another one. That's a non-periodic function. Okay, let me grab a chart. One that's a little different, not just a normal one. Let's try. I'm fine with this one. So max and min here are 1 and 1 for this one. 1 and -1. Good. So if we take a look at our other things, our direction of start, so starting from a point here, it's positive if it goes up, and if we started here and it went down, it would be negative. Okay? The period is how long it takes to do a full rotation to get back to the start. In this case, the period of this one, let's say it's 6. Let's just estimate it at 6. See how long it takes to go through a full rotation before it restarts itself. Okay? Now, if we take a look at our chart here, the axis of the curve is the line that goes through the middle of the curve. Some people call it the midpoint of the curve, but axis of the curve goes through the midpoint. And the way you get that is you add the max and min together and divide by 2. In this case, 1 plus -1 divided by 2 equals 0. An amplitude, and I love that McCann used the amplitude in an earlier question. He said the amplitude of this changed. Okay? So we take a look here, the max minus the min divided by 2. Okay? So this one's kind of confusing. In the way max minus min you'd think would come to 0, but it doesn't. Because if you think about this, our max was 1, our min was -1. So max minus min is actually 1 minus -1. And these two negatives create a positive. So 2 divided by 1 equals 1. Oops, what was my hand doing? Okay? 1, right? So our amplitude is 1. As you can see here, from the max to the axis symmetry, 1. From the min to the axis symmetry, also 1. Okay? Let's see if I can pull in a different chart here. Let's look at this chart. Snapshot. Okay. So let's take a look at this one. So this is a cycle of proportion of the moon visible. So we're looking at the moon each day, right? Sometimes there's no moon, sometimes there's a full moon, right? And it goes through a cycle, right? And it's actually, the moon that we see is periodic, as in it just keeps repeating itself. So, let's do waterfall method here, okay? So I want you to type in to chat we'll work with max and min first. What's the max for this periodic function? the max. Why do you guys all have negatives on here? It's 1. Yeah. Good. And what's the min? What's the minimum number? Good. Now what would be your, what's your period here? What's the period? That's days across the bottom, okay? What's the period? We have 30 days, 29 days if you want to be technical. So we can estimate 30 days on our chart. If you want to be super technical, 29 days. Now, you could find the period in a couple different ways, right? Some people would have looked from this spot here to this spot here, which makes sense. You could have looked from this spot up here to this spot up there, same difference. Or you could have taken the middle number. I could have taken a middle number around, let's say, those are really nice because they're kind of laying on lines. But I could have went from here, right, I follow up, down, and before it comes up again, I could go from there. So it doesn't have to be a certain point, okay? Are we missing any other definitions here? We can look at our axis of the curve. Where's our axis of the curve happen? So we add our max and min and divide by 2. Okay? Where's our axis of a curve for this one? Can anyone tell me? What line cuts this curve in half? So our max plus our min. Good. Max plus min, good. So 1's our max plus our min divided by 2. Good. Now, our amplitude. Now, one thing I didn't add on there, amplitude is always positive. Okay? We could have an axis of the curve that's negative, but our amplitude is always positive. That is 1 minus our max minus our min divided by 2. In this case, it's 1 over 2 again, which equals a half. Which makes sense because if I cut this straight down the middle, beautifully down the middle, it's half up and over here, half down. Okay, let's get you a difficult one. Let's find a hard one for us to work through. How are we getting this so far? Thumbs up, thumbs down? Good? Okay. Let me find another. So this is all, this little note that we did here is all we're doing for today for this. Periodic function. These ones shifted periodic functions. Disappear on me. And some of these like to come over and some don't. Who's in your background, Mark? One. Alright. Let me try to pull one more over before I... Okay, I'll grab this one first. we'll work through the technical aspects of this, and then I'll ask you to kind of explain it in real world terms. Okay? So, first question, is this periodic or not? Yes or no?
Yes.
Yes. Okay. What is our max? So, let's figure out what our max is here. Good. So max is 2. Perfect. What's our min? Min is 0. Oh, you know we forgot to do on the last one was our period. Okay. What's our period for this one? How long does it take it to go through a full cycle? Good. 2 seconds. Good. What's our axis of symmetry? Do we agree with Tanner here? Good. And what's our amplitude? You can't agree with yourself, Tanner. I just saw that. Good. Good. Now here's a secondary question for you. So we can pull all that information out. That's wonderful. Actually really important once we start. If we can pull this information out every time, it's going to help us because we're going to start mathematically analyzing these and applying formulas to them and adjusting them. So this is a machine at a factory chops rubber hose into 5-meter lengths. What else can you determine from the graph? So we determined this. Okay. Can we determine some like real world explanations for this machine? Because you walked in the factory and told, well, that's got a max of 2, min of 2, periodic of 2 seconds, the axis of symmetry is 1, and the amplitude is 1. They probably kick you off the factory floor, right? But and what do those things mean in real terms, right? If you had to say this machine we're cutting lengths? Yeah, hoses. Can you answer that question for me? The machine cuts hose every blank seconds. Every 5 seconds? Every 2 seconds? Good. It cuts every 2 seconds. Oops. Because it takes it 2 seconds to go through the cycle, right? So every 2 seconds, if I went to this part here, right, there's where it cuts, right there. If I go ahead and see where it cuts again, and where it cuts again, right, it's cutting every 2 seconds. Hit, 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 hit. Okay, let's answer this question then. How high does the blade go? Oops. How high does the blade go above the hose? Good. 2 centimeters. Now, how much time does it take for the blade to go up and down? Just the moving action, not the resting action. Good job, Ben. Oh, where'd 6 come from? Dylan? So the answer is 0.5 seconds, because if you see it kind of go, if you go down, by the time it starts to move, boom, boom, that's half a second. That's no problem. If you were thinking it, someone else would have been thinking it. Okay. And that is our lesson for today. Let me take a look at your homework to make sure. So we're on Thursday homework. We're on the very first block of Thursday homework. Okay? So the first question here is determine if they're periodic. Okay, just by your answer. Tell me if it's periodic, yes or no. Okay. The second question here, determine the period, which we know how to do, amplitude, and I'm not going to worry about domain and range right now because I don't want everyone to have crazy flashbacks. Although, let's kind of look at it real quick. Domain looks at left to right. Actually, we're not going to worry about that right now. Okay? Oh, here's one thing I didn't do. Let's do this question for you right now. Okay? It says find the values at F2, F4, and F7. Okay? So the way you find the value at F2 is we're just going to take a look at when the x-axis is 2. So go along the x-axis and we circle it. And the value for this one, if we look here, is 0. If we go to the 4, F4, we go along the x-axis to 4, we go down to where 4 is. This would be -1. Now can we type in chat what we think 7.5 would be? What would 7.5 be? If you had to take an educated guess. What's f of 7.5? Lago says 3. McCann says 2. Brooke says -1. Okay. So if I took here, I want to find 7.5, it would be approximately right here, right? So I go up. Now I would kind of take, this is a really good diagram, so either 2 or 3 I would accept right now, okay? Because 7.5 is right there along the x-axis, okay? Is there another one here I can find? There's EKG. No. So, there is a charting one here. You guys don't have to do the chart if you don't wish to for that. So there's a couple questions there. They're all working with interpreting, and the first part is determine if it's sine function, and then saying, okay, what's the max value, what's the what's the min value along those lines. Okay? Find 2 other values, x gets the same values. Oh, here's one. So it asks you to find 2 values of x that give the same values you find in part A. Can someone else give me a, let me see here. F of what is equal to f of 2? Okay. Can someone give me... Oh. Can someone give me another value I could put in here? Okay, 4.5 would be one. Do we have another one? Sweet. Ben said 4.5. Not -2. -2 is going to be over here, can it? Right? 6 would be another one. So any time where it crosses here. Eight would be... Oh, 8's up here though, right, Tanner? Okay. So any one of these ones here, I'll just dot them. So this one here, whatever value that is, that's at like 3.5. This is 6. That looks like 7-ish. Okay. Does that make sense to everyone? That question? Alright, I'm going to do my attendance check, and then you guys are free to do your homework. And I have to make the QR code here real quick. My QR code maker go. Okay. And then try to be back for, we have like an hour, so try to be back for